Good evening, dear friends. I am back with another exciting problem from RMO Regional Mathematical Olympiad 2019. So let's begin with the problem. Now, according to the problem, there is a triangle ABC, right? So let this be a triangle ABC, and it's given that its centroid is G. So first of all, let's draw it circumcircle omega, that is given. Circumcircle ohm, sorry, that is given. So let's draw it first. Right, so this is its circumcircle, and now let's draw its its centroid. So the centroid is the intersecting point of all the medians. So first of all, we have to draw all the medians. This is the diagram when we draw all the medians. Now this point would be the centroid, right? So let's first of all label this point as G. Let this points be A, B, C, D, E, and F. Right. Now it is saying that extend AG, BG, and CG to meet the circle ohm again. Right. So first of all, let's extend all these. So that would be like extending this till here, extending this till here. Let's shift it a bit here. This thing, and extending this point till there. So I'm clear till now. Right. Let's label these points as A dash, B dash, C dash. Right. Now let's draw these boundary balls as well, because it would make easier for us to understand the question later. Right. So let's draw these lines as well. The first line, the second line, the third line, fourth line, fifth line, and supposedly the last line. Alright. Now moving on with the question. Suppose angle BAC. So let's label the angles with different colors so it's easy for us to identify it. Angle BAC equals angle A1, A dash. Okay, my labeling was a bit wrong, so first label it correctly. A1, B1 and C1. Suppose angle BAC is equal to angle A1, B1 and C1. A1, B1 and C1. So first let's draw an inner angle also, so that it's like it gives us more clarity on where the angles are. Right, so this is the first angle, the second angle, and third angle. Right, now moving on, what we have been given is that angle BAC equals angle A1, B1 and C1, this angle. Right, the next thing is that the angle ABC equals angle A1, C1 and B1. So this angle. And the last thing we are provided with is that the angle ACB equals to the angle ACB equals to the angle B1, A1 and C1, B1, A1, C1. So this angle. Alright. Now we have to prove that ABC and A1B1C1 are equitriangles, right? So first of all, let's take this angle as x and whole angle as theta. So let's write the assumptions here. BAC equals theta, right? So if this is theta, this would be theta minus x, of course. All right. Now seeing it, if this angle is x, right, with the base as A1, no, with the base as A1C, if this angle is x, so let me label this as well. With the base A1C, if this angle is x, right, so with the base A1C, this angle also ought to be x, the angle, this one, this part only, right? So let's label it first. Right, so this angle is also x, right? Now similarly with A1C1, A1C as base, this angle would also be equals to x, and similarly with this as the base, this angle would also be equal to x, right? Now taking this as the base, no, wait, so let's take right, this angle is x, so right, wait a moment, this angle, right, right, so that would be wrong. If I take so what we can do is that we can also say that the angle C1A1 should be theta. Why? Because like if angle BAC is theta, right, so for the base BC, angle B1 and C would also be theta, so this angle would be theta minus of x. And now taking this as the base BC, if this angle is theta, this angle is x, this angle is theta, this angle will be theta minus x. Alright, and now if this angle is theta minus x, so this angle would be theta, right? And theta minus x, okay. Wait, x, this angle is x, now we have to prove that, wait a moment, this angle is x, so is this, okay. We know that this angle would also be x, alright, because this whole angle is theta, so this angle would be x. If this angle is x, so right, so if we take C1B as the base, this angle is x, so C1B A should also be x, so this angle would also be x with that only, because this angle is x, taking C1B as the base, this angle would also be x. Alright, now what we can do ahead is that right, so if this angle equals x and if this angle equals x, what does this angle equal? we can get it, right? Because this angle is x. Not a lot of things right now. Right. So if taking C1B as the base, if this angle equals x, then this angle also equals x. Alright. Now if this angle equals x, taking the lines C1C and the lines B1 BA1, we have to say that with BC as transversal, BA1 should be parallel to C1C in order to make both these angles x, the angle A1BC and the angle C1CB. For these to be x, these two lines have to be parallel, right? Now similarly we can also say that, because if these two lines are parallel, by proving same way, like taking this as y, this as z, we can also say that the lines A1C is parallel to B1B, and the lines A1C, this line is to this line is to this, and then AB1 should be parallel with AB1 only, with this. See, wait a moment. B1 would be parallel to this. This lines will be parallel to this, right? So AB1 would be parallel to C1C, and A1C would be parallel to BB1, and this would also be parallel to A1C. Alright, and like this only. But now what we can say, like, let this point be E, right? I have written that here, that this point is E. So if this point is E, what we can say is that E is the midpoint, right? If E is the midpoint and the line B1 is parallel to A1C, so in triangle ACC1, point E equals to midpoint, and by midpoint theorem, G has to be the midpoint of C1C, right? So if G is the midpoint of C1C, we can similarly say that if G is the midpoint of C1C, G midpoint C1C, G has to be the midpoint of B1B and A1A. Similarly, with the same proof, we can prove that also, but that would be lengthy, so I'm just discussing it, that as we have already proved for one thing, it is easy to prove for the other things as well, taking angle y and z and so on, right? So if this angle equals, so is G the midpoint of B1B and A1A, so what we can say is that G is the circumcenter, right? So if G is the circumcenter, because circumcenter has this property that it's all the radius are equal. So if C1G is equals to CG, GB1 equals to GB, GA1 equals to GA, therefore these also like this equals this equals this equals this. So G has to be the circumcenter, then only will this be possible, and these all have to be the radius of the circle. Alright, now if G is the circumcenter, G is the centroid as well, as G is the circumcenter as well as centroid, this property is only possible in an equilateral triangle, because in an isosceles triangle the circumcenter and the centroid are different. That the circumcenter and the centroid have to be the same. This is only in the equilateral triangle. In isosceles triangle, it is that all these points lie in the same line and are collinear. The circumcenter, centroid, orthocenter, these all lie in the same line and are collinear. But only in the equilateral triangle is this possible that the circumcenter and the centroid both are equal, right? So we hence are able to prove that A1B1C and A1C1B1 are equilateral triangle. Therefore, ABC, triangle ABC, triangle A1B1C1 are equitriangle. So this is the answer to our problem of RMO. This was not an easy problem and we also got confused a bit. But I hope you liked the video. Please subscribe to my channel and please press the bell icon. Thank you for watching.